anytime you are working with a two-way table, you want to make sure your totals are completed, okay? The reason is you never know when you're going to need them, okay? So for full-time, what is the total of full-time? How many people were surveyed that checked full-time? Catherine? Perfect. Okay, how about part-time? Go ahead, Catherine. 775. And then unemployed. You seem to be it, my friend. Go ahead. 823. Okay, so you want to do the totals even though you may not use them. Okay, it is good to know because you never know what the question is going to ask. Okay, then we go through and figure out the total of the age groups. So how many 0 to 17? Yes? 559. How many from 18 to 25? Go ahead. You got this one. 536. Then good. And then the 778. Making a total number of people 3,179. Okay. So now, looking at our questions, all right, we see the word given a lot. So if a person in this town is selected at random, find the probability that the individual is employed part-time, given that he or she is between the ages of 35 and 49. Go ahead, Kip. Excellent. So whatever comes after given, okay, 35 to 49, this is your denominator. So 864. And out of that total, how many of them are part-time? Is 179. Excellent. Then for B, if a person in the town is randomly selected, what is the probability that the individual is unemployed, given that he or she is over 50? Troy. Excellent. 173, 778. Okay. Over 50, the total was 778. Out of that total, how many of them were unemployed is 173. Okay. Now we look at C. A person from the town is randomly selected. What is the probability that the individual is employed full-time given he or she is between 18 to 49? Go ahead, Kip. Excellent. Okay, before that, 18 to 49, you will be circling the total of these three rows. So you have 536, 442, and 864, making the denominator of 1,842. And then how many of those are employed full-time? Let's go to full-time, 185 plus 348 plus 581 gave you 1,114, which reduces to what Kip said, 557 over 921. Excellent. Okay. And then the last one, which was D on the next page. A person from the town is randomly selected. What is the probability the individual is employed part-time given he or she has worked at least 35 years? Go ahead, Kip. Be careful. What did you get before that? The denominator is correct. There's 1642. At least 35 years old, employed part-time. So, at least 35 are these two here. You see what you did? Yep. 179 plus 162 gives you 341 over 1,642. Okay? So wherever you see that word given, whatever comes after it is your denominator. Okay? That's going to go hand in hand with some of the problems we're going to do next. Okay? So there's only been 3 people that have answered. So those 3 are off the hook right now. 4 people. Okay? The rest of you will be answering these next ones. Okay? So, looking at number 10, you guys have it as number 7, I guess. The numbers were all, nope. Number 6, maybe? I don't know. Okay, so consider a bag with marbles. 3 blue, 2 red, and 5 green. How many do we have in total? Eliza? 10. Okay, we have 10 in total. Okay, 3 marbles are drawn in a sequence. They're going to give you a specific sequence. Doesn't mean all 3 are drawn. So, it says without replacement. That makes it dependent, meaning it's not going back in. So, the probability of the second draw is blue, given you have already chose a red. So, if we already chose a red, what is our total down to? 9. Out of those 9, how many of them are blue? 3. So 3/9 is 1/3. Okay, so the notation sets it up for you. Okay, probability the second draw is blue, given the first draw was already blue. So if we already took a blue, we're down to 9. Then what, Nick? 2/9. Good. Okay. Then the third one. Probability the third draw is blue, given the first draw was red and the second one was blue. Eliza? 1/4. Excellent. We already chose 2, so the total is down to 8. We already chose a blue as well, so instead of 3, we're down to 2, which is 1/4. Now, the last one. Probability the first draw was blue, given the first draw was red. 0. Can't happen. Okay? So now, as we talked about previously, cards, again, that's what we look at for probability all the time. Okay? So some key components of cards, there are 12 face cards, which are king, queen, and jack. Okay? There are 4 suits, which contain 13 cards each. Okay? Those suits are clubs, diamonds, hearts, and spades. Okay? So this first one, probability a queen is drawn given you have face cards. So how many face cards do we have? 12. Out of those 12, how many of them are queen? 4. So 4 over 12, 1/3. Okay? So if you notice, whatever came second is your denominator. All right? So probability an ace is chosen given it's out of lettered cards. So how many lettered cards are there? 16. Good. Out of those 16, how many of them are aces? 4. So 4 out of 16, 1/4. Okay. The next one, probability. Heart with a number, given it's a red card. So how many red cards are there? 26. Out of those 26, how many of them are hearts with a number? 9. So 9 out of 26. Good. Okay. The next one, probability a card with a letter, given it's out of kings. How many kings do we have? 4. How many of those have letters? All 4. So 4 out of 4. This one. Good. Okay. Next one. Face cards. How many face cards do we have? 12. Out of those 12, how many of them have a number less than 6? None, right? 0 out of 12. All right. The last one. Probability of an odd number given set of numbered cards. So how many numbered cards do we have? 36. Good. Out of those 36, how many of them are an odd number? Kaden? 16. 16 out of 36 reduces to 4/9. Okay. All right. So that is also called conditional probability, where it's dependent events. Whatever comes second in that notation is your denominator. Okay. So I want you to turn. You're going to turn back to this one with percentages. Okay. In the same note packet. Okay. You guys will see it. It's labeled number 4 when it should be 6. It's after passed and failed chart. Okay? So this is another way to fill out a two-way table. Okay? You are now given percentages, and it's out of 120 students. Okay? So it's telling you 40% of students are juniors. So how do we figure out exactly how many juniors there are? What do we do? Okay? Good. 0.4 times 120. 0.4 times 120. So how many juniors? 48. Okay? Let's look at the next one. 25% of juniors study biology. Charlie? How'd you get it? 25 times 48 gives you 12 of juniors who study biology. Then 35% of students are seniors who study physics. So what do we do there? David, what do we do there? Good. 0.35 times 120. So how many of the students are seniors who study physics? 42. And where will that go in the chart? Someone else. Eleanor? Good. So we had 42. Excellent. Okay. 45% of students study physics. Go ahead, Caitlin. Which is 54. Good. Okay. 30% of students study chem. Pearson, what do you have? 36. 0.3 times 120, which is 36. Okay. So right now we filled out part of the table. What I want you to do, your first task, is to complete the table, okay, then answer the questions below in reduced fraction form, okay? Complete the chart, then answer the questions below. All right, so the first one, here's the chart filled out, okay, completely. And then for B, what is the probability that a student studies biology? It was 30 out of 120, which reduces to 1/4. So good job for that one. And then for C, what is the probability that a student is a senior and does not study biology? Okay. Now, keep in mind, you're looking at the total, which is 120. But it says and. So with a two-way table, You are just looking where they have those two events in common. So, does not study bio and is a senior. It's 12 plus 42, which is 54, over 120, which reduces to 9/20ths. Okay? So, anytime it says and it's probability that the student, okay, on a two-way table, okay, on a two-way table, you're looking for where they both have in common out of the total. You're not adding, multiplying, whatever the rule is. You're not doing that. You're just looking to see where they have in common. It's the intersection. Okay, then for D, what is the probability? Same thing. What is the probability that the student is a junior and studies chemistry? So junior in chemistry is 24 out of 120, which is 1/5. So we should be jotting this down or making notes if you did not get this correct. Okay, this is what we do for practice. What is the probability the student is a junior and studies chem? It's where they overlap. Okay. Then for E, what is the probability the student is not a junior? It's 72 out of 120, which reduces to 3/5. So what we see on the board is correct. Then we have G, nope, F. What is the probability the student does not study biology? It was 90 over 120. 90 over 120. The student that does not study bio, you're adding 36 plus 54. Okay, so does not study bio, 90 over 120, which is 3/4. Then they ask you a different way. What is the probability the student chosen at random studies chem or physics? Again, 90 out of 120, which is 3/4, which is correct on the board. Okay. Then for H, what is the probability that a randomly chosen junior? So now it's narrowing the playing field. Okay. Randomly chosen junior. So the denominator is going to be 12. Studies physics. So 12 out of 48 is 1/4, which is correct on the board. And the last one, what is the probability the randomly chosen chemistry student, so now we're looking at a 36, is a senior? 12 out of 36, which is 1/3. Okay? So one thing with probability, we have to pay attention to the wording and what it's asking for. Okay? For two-way tables, anytime you see the word and, you're looking where they have both events in common. Okay? If it says or, you're adding still. Okay? So today, we are moving on to set theory. You do have a quiz on probability on Wednesday. It was originally going to be Monday, but it's going to be Wednesday now. Okay? You have a quiz on probability next Wednesday. We are finishing 3.3 today. We will have practice on 3.3 tonight. On Thursday, there's a bunch of things happening. Expect 1 or 2 formatives, okay, on Thursday and on Monday, okay? You will have a bunch of review. We'll have pretty much group workstation, something going on like that, in terms of all aspects of probability. We've done this short and sweet, but now can you apply what we've learned on many different questions, okay? This, again, probability is all over the SATs, okay? Two-way tables all over the SATs. So it's imperative that we understand these concepts, all right? Take out your notes. And turn to page 9, I think. 8 or 9 or 10. It's page 9, where it says set theory. Now, some of you probably saw this on the key. You're like, what the heck is that? the U or the upside down U, this is what it is. Okay, I'm so used to doing those symbols that it just came out like that. So, one thing with set theory, okay, sets are a collection of distinct objects. So, for example, or things. If we had a set, universal set, let's just say, would be all of you in this class, okay? Set A, represented capital A, would be my sophomores, okay? Set B, with a capital B, would be my juniors, okay? Set C would be my freshmen, okay? Those sets do not repeat itself, okay? Because think of it this way. You, in that particular instance, you cannot be a sophomore and a junior, right? But there's other instances where you might see the same number, the same thing that appears in both sets. That's what they have in common, okay? So here's examples of sets denoted as a capital letter. You're going to see no repeats. Set A, and we remember this notation, right? With the squiggly brackets, set notation is back, where you have to list it, okay? Set A is 1, 4, 6, 10, 12. Set B, example, all ninth graders. Set C, turtles, penguins, mice, and bears, okay? All those things in this set are called elements, okay? To denote if an element is contained in a set, we use this letter E, this kind of Greek letter E, okay, that says, for example, 4 is in set A. However, 5 is not, where we put the line through it, okay? So in set B, we have all ninth graders. However, what it won't be in set B? What's an example that won't be in set B? Yeah. Turtles, 10th graders, right? Anything like that. Okay? All 10th graders, turtles, whatever, will not be in set B. Okay? In set C, turtles are in set C, but dolphins are not. Okay? So that's how you denote if an element is within that set. Okay? So now, we get to a Venn diagram. Okay? We want to determine the following. What elements are in set A? What elements are in set A? Charlie? 1, 2, 3. Excellent. Okay, it's all of this circle. What elements are in set B? Go ahead, Riley. Good. Okay, all the elements in B. Okay, what elements do set A and set B have in common? Keelan? 3. Okay, what elements does set A have that set B does not? David? 1 and 2. Good. Okay, all right. So the next example, you guys are going to try. We have 2 different sets. We have animals, things that fly, and then both. Okay? Here are the questions I want you to answer. Take about a minute. Okay. How many elements are in the set of things that fly? Jaden. Yep. 7 elements. It's this whole circle. Okay? Now, what elements are animals that cannot fly? Go ahead, Campbell. Perfect. Caterpillar, shark, and horse. Good. Okay. Write the set of animals that can fly. Go ahead, Kim. Good. Cat, bird, butterfly, and bee. Okay, so that was asked a different way. However, it's where they both are in common. Okay, how many of you got all three of those correct? Awesome. Okay, so next thing is notation. Okay, next thing is notation. This is where set theory comes in. So the universal set is the set containing all objects or elements. Okay, so you guys would be the universal set. All right, the null set or empty set is where there's no elements. Okay, so anytime there's no elements, say if you're doing any sort of these notations and there's nothing that's in it, it's the null set or empty set. Right, so a few things to consider. Anytime we have this upside down U, this is called the intersection where they both occur. Okay, so for this one here, this type of question, write the set of animals that can fly is where the intersection happens. Okay, where they both occur. Another key one that we tend to mess up a lot is the union, where it's this U. Okay, it means or. Okay, it's either in A or B or both. The biggest one that we always forget anytime it says or is this middle piece. That is included in the or statement. Okay, it's A or B or both. Okay, then the next one is denoted with the complement. A with the little c or the line over it. Another one is A with a little dash tick mark there. Okay, it's elements that do not belong in that set. So for set A that does not belong in set A, we completely not shade A, but everything else, including the outside. Okay, so all of these notations are key. There's going to be times we incorporate all. Okay, so we're going to interpret what these mean in words. We have the upside down U. So this means in set A and in set B and in set C. Okay, then for the next one with that little c, not in set B. Okay, not in set B. Right. The next one, in set B or set C or set D or in all three. Okay, what it looks like on a Venn diagram with the triple set. Okay, this is what a triple Venn diagram looks like. It would be all three circles, including the overlaps shaded in. Okay. The last one for D. Not in A or B or both. It's pretty much the outside of the Venn diagram. Okay. So now we're going to get to an example with three different sets. Okay. Set F, it's Haley and Taylor. Set G, Mom, Dad, and Taylor. Set E, Mom, Haley, and Muddy. And the universal set includes Mom, Dad, Haley, Taylor, Muddy. So that's everybody that has to be included. Okay? Now we're going to go through notation. Who is in F and G? Eliza? F and G. So it's the intersection of them both. Pearson? Taylor. Only Taylor. Okay, it's where Taylor's in common in both of those. Then the next one for B, who is in F or G or both? Who is in F or G or both? Yep. Perfect. Haley, Taylor, Mom, and Dad. Okay. Everyone okay so far? So the next one, not in E. So who is not in E? Grant? Perfect. Okay. We all okay? All right. The next one, who is in F and G and E? Basically, in all three. Is there anyone in all three? Good. Null or empty set. There is no one in there. All right. Then for E, this means not in F and G. So basically, it's not in the intersection. We already found what F and G, who was in F and G. Who was in F and G? Taylor. So who's not in that intersection? Kate? Okay. Anybody else? And Muddy, good. It's everyone else in the universal set. Okay. Now in number 6, or F it should be, okay? Not in F, but in E. And it's in E. Go ahead, Charlie. Mom and Muddy, good. Now, some of you might be like, well, that's kind of hard to tell with it lists like that, right? You could create a Venn diagram as well, which might be easier for you to see, which we're going to actually look at right now. Okay? Any questions right this second? Let's go to the next one. Now we're going to fill out the Venn diagram and then answer the questions. Okay? So we have set A and set B. In set A is January, February, March, April, September, and December. Set B, April, May, September, November. The universal set contains all 12 months. So, what months are in both A and B? Yep, Kaylin. April and September. So that goes right there in the middle. Okay. What months, and you can see the overlap here. Okay. What months are only in set A? What months are only in set A? Christian. Good. January, February, March, December. Okay. Which months are only in set B? Tell me, what do you think? Good. Excellent. Okay. Now, which months are not in either set? Go ahead, Kate. Yeah. Which will go on the outside. Okay. So now, the notation. A and B. Which months are in A and B? Go ahead, Catherine. April and September. Good. Okay. Which months are not in A and B, meaning not in the intersection? Which months are not in that middle piece? Yep, Jax. Go ahead. Did you have your hand raised or no? Jax. Okay, it's okay. Ryder. Would I add anything else? Yep. Some people have asked in my other classes, is there a shortcut to doing this instead of writing it all out? No. Do you have to have it in order? No. Because if you understand what this notation is representing, that's all that matters. If you wanted to put this in, which I did on mine, January, February, March, in order, you can. Not necessary. Okay? The reason is, if you understand this, you're golden. All right? So the last one here. A or B or both. That's what that notation is. What months would be in there? Go ahead, Grant. So January, February, March, December, April, September, May, and November. Okay? So you guys are going to work on one on your own, the last one. Okay? You have F and G. Okay? The universal set contains, pay attention, -3 to 18. Okay? -3 to 18 is the universal set. Okay? So fill out your Venn diagram first, then answer the questions. If you did bring your course selection, have that out. Okay? If you didn't, no worries. Yep. All right, guys, we're going to go through this one to make sure we're all on the same page. The more in detail as we get to the ones that require, a lot of listing, that will be posted, okay? We will go through it, but just so you can visually see it. So, what is in F and G? Let's go through this quickly if you got it done. Eleanor. 5, 8, and 12. Good. What is in F or G or both? Noella. Perfect. Good. All right. What is not in F? Riley? What else would be a part of that? All the outside. So, not in F completely excludes this circle. So it's -3, 0, 17, and all these numbers on the outside. Okay? Then not in G would be the opposite. 2, 7, 9, and all the numbers on the outside. Okay? Then, what is not in F and G? Eleanor? Anything else? Not the middle part. Good. So, not in F and G is 279, -3, 0, 17, and everything on the outside. Okay? And then the last one. What is not in F, but it's in G? So basically only G. What would that be? Yep. Yep. Good. Awesome. How many of you did get all of those correct? Great. If you missed any numbers, this will be posted or is posted or will be posted. So make sure you check your answers. Your homework is the 3.3 practice. Again, everything will be released in a little bit. Okay? Your homework is the 3.3 practice. On Thursday, you're going to expect a warm-up first. Okay? After the warm-up will be a formative. Okay? Then we're jumping into one of the first practice reviews. Okay? There will be an exit ticket, which is on a Google form, so make sure you have some sort of device with you. Okay? Then on Monday, jumping right in with a formative, another review, and quizzes, which is a formative online. Okay? Then a few other things. All right? So that's the deal for the next 2 classes. All right? And then your quiz is on Wednesday. All right? So you may get started on that practice.